In this video, let's practice inverse functions. Inverse functions are the functions that basically undo each other, or they sometimes called anti-functions. Inverse function is a function that reverses another function. And by reversing means if the function f is applied to an input x and gives you the result of y, then applying its reverse function g to y gives you the result x, and vice versa. i.e., if you have f of x equals y, then g of y gives you x. Maybe it's not very clear what is going on, and here is one of the images we usually show. If f, and f is the function is a rule, assigns for each input and output, and in this case for a, f assigned number 3, for b it assigned 1, for c it assigned 2. Then the question is, can we reverse the process, and then if I give you only right hand side, can you go back and find what input gave me 3? Oh, a gave me 3. So now I'm actually having 3 in my as a known data, and then I say 3 came from a. How did I get 2? 2, let's see, going back, came from c. So now it tells you c gave me 2. How did I get 1? Let's see, going back, that's b. 1 came from b. So this little notation means f minus 1. Look, we read it f minus 1, and it doesn't mean 1 over f. It means a notation for the inverse function, f minus 1. If that is still not clear, then let me introduce you the idea of the machine. So each function is basically a machine that does something with your input. You threw, say, x into the machine f of x. F of x is working on your input, doing something, and then gives you the output. Let's call it y, or f of x equals y, right? So the inverse is a different looking machine, maybe like this. And what it takes your output y, swallows it, working, and now we're going to call it f minus 1 of x, f inverse. And it's not of x anymore, because you can see that the input for the inverse now is y. So it takes your y, working on it really hard, and then gives you as the answer, what does it give you? What do you think? What originally gave you y. So it should spit out x. And that's what we call inverse functions. So you started from your input, went to the output, threw the output into the inverse, and ended up with the same input. That's the idea of two inverse functions. Let's practice now. So we're giving with two functions, 1 over 3x and 1 over 3x. One called f of x and another one is g of x. Let's see if they're inverse of each other. To find if they're inverse of each other, I need to check this idea that f of x gives me y, then g of y gives me x. In other terms, I actually need to check the composition of two functions. If both compositions give you x, then the answer is yes, these two functions are inverse to each other based on this little explanation with the machines. We started with x, we ended with x. When we applied both machines in any order, this way or this way. So we hope to get x in those cases, in two cases. Let's see if we do. So f at g. Watch my video about compositions of functions to do that faster. F of g means I will take f, which is, I will do f at, what is g? G is 1 over 3x. That's how you should see this notation. Now I'm looking at f. F is the function over here. It's first function. So now everywhere I see input in the first function, I will plug 1 over 3x there. So it's going to be 1 over 3 input, and my input is 1 over 3x. Does that make sense? Again, please watch the video that's called Compositions of Functions. It will pop up at the end of this video. Now simplify. 3 over 3 goes away, and I end up with the fraction 1 over x. What is 1 over x? That's just x. Makes sense? Multiply by the reciprocal of 1 over x, and that's x. So we got x like we wanted. That's good. Now, let's hope that we get x second time. But this time we start with g, where we plugged in f of x. What is my g? G is, let's keep writing as g for now, and f of x is 1 over 3x. Now I'm gonna look what my g is. G is function number 2. So here we used function number 1. Now I'm using function number 2. Everywhere I see x, I will put my f now, and f is 1 over 3x. So it's gonna be 1 over 3 input, and input is 1 over 3x. And it seems like the situation repeats, so indeed we're gonna get x one more time. That means the answer is yes. F and g are inverses of each other, because no matter which order we apply them to each other, we go back to the input, and that's the property or definition of the inverse function. You reversed whatever the other function did and went back to the input x. Let's check the same thing for the two other functions, x plus 2 and x plus 2. So f at g of x at x plus 2. So everywhere I see input, it's over here in my f function 1. So I'm going to use 1. I will plug in x plus 2. So I have input plus 2, but I need to plug x plus 2 where I see input. So it's going to be x plus 2 and then plus 2. So again, I just plugged here my x plus 2. That is x plus 4. Okay. Let's do the reverse process. G at x plus 2. The situation is the same, but now I'm using second function, which is g. Here I have x plus 2. Instead of x, I will plug x plus 2, so I'll have x plus 2 plus 2, and it is x plus 4. So those two answers are the same, but they are not x. So they did not give me the original input. They gave me some kind of completely different result. That's why the answer is that f and g are not inverses of each other, even though the answer is the same. And they did not give me the original input. What is the original input? Original input is x. Hopefully this was clear or not. And I'm making a second part of this video where I'm going to be talking about more examples which will look like these. Let's answer a couple of questions about the inverse functions. Find the inverse function from the given expression, and then find the composition of H and H inverse, what this is going to give you. Hopefully, see you in the next video.